All right, everyone, we are back, and we are going to do our question 2, bend, don't break. So we have a polymer beam, length of this, width of this, thickness of this, can't exceed the yield strength of the red curve below, and the failure stress. So cannot exceed, the failure stress or the yield strength and the failure stress. So let's go ahead and let's calculate that value. Must exceed the yield strength of the red curve below and the failure stress. So let's go ahead and check it out. So I'm going to quit my kernel. So I'm going to do evaluation, quit kernel. So let's look at our beam. It's a polymer, so we know. Good. My Mathematica is a little bit slow. Oops, that's not responding. Always make sure to save often. So I'm going to say Young's modulus polymer. So my length is equal to 90 centimeters. My width is 42 millimeters. And then my thickness is 0.12 centimeters. Good. So let's go through here. So how are we loading the system? So we have a positive 7 times 10 to the 3. I'm starting my 0 right here on the left-hand side. And so that's 7 kilonewtons. And I'm going to apply that right at L divided by 5. And then I'm going to take this, and then I'm going to go down minus 2 kilonewtons at 3. Actually, 2L divided by 3. What are my boundary conditions? They're equal for both sides. Y of 0 is equal to 0. Y prime of 0 equals 0. Y prime of L. Yep. So let's do desolve here. We've got our values over here. Let's plot our function. And then we're going to see. All right. So that's our plot. We can also find the moment. So let's go ahead. Let's do that right now. So what is the maximum deflection? So looks like we're going to be looking around 0.3, and that find minimum, we're going to say find maximum, 0.3. And while we do that, we'll run this code here. We can hide this input here. Let's find our moment. So we need to find maximum moment here, probably searching at 0. We'll get back to that. Okay, so this is my deflection. That's a lot. Maximum stress. So Sinbad max, we're going to take it positive here, times h over 2, and then here. So that is going to be, so about, makes sense. Is that negative making sense? Because our largest value right here, and if we're going to the top of the beam, top of the beam is under compression, makes sense. So yeah, that's gigapascals, that's hundreds of, actually it's a little close, 100 megapascal. No, it's not that close. So it's not going to work. It failed. It exceeds both the yield stress and the failure stress. So it will not work for the maximum. At the maximum deflection, is the curvature positive or negative? Ooh, good question. It will be negative curvature. So sad face. So excellent. Now I'm testing materials here. So this is long time. So whatever this material is, at long times, I should behave more, at very, very short times, I should behave like a solid. So here, this is my G prime. This is my G double prime. So I already know that. Material B is a solid. So I'm going to say B is here. So my open symbols for B, so if it's a solid, it's just basically like this is here, and then my filled in ones, right? I'm keeping the same notation. My open symbol is that. So that's a solid. Material C behaves like a viscoelastic fluid that's more liquid than material A. So I'm going to say my blue. So material C, so viscoelastic. So this is the crossover point here where it starts to behave like a liquid. So I need to actually shift mine. I'm going to now make for this one. This is going to be my solid, and then this is going to be, I'm going to make this my G prime. So I'm going to have my solid be like right here, or my liquid, excuse me, and then my solid just be like right over here, and then drops like that. Excellent. So that captures the behavior. So we answer this, we answer this. Excellent. Range each material's relaxation time. So time we can actually see. So my tau for C is less than my tau for A, which is less than my tau for material B. So my material B has the longest relaxation time. Makes sense. Excellent. And glass transition temperature will behave exactly the same way. So time, temperature, equivalence. Fantastic. That's it. We'll see you in the next problem. Thanks. Bye.